Okay. T13, T13, T13 equals to 0.020875 T14 plus 0.020875 multiplied by T12. So T14 is 0. T14 is 0. But T12 is equivalent to 0.020901. So whole thing divided by 2.04175. So 0 plus 0.020875 multiplied by 0.020 091, yeah? 091, 091, sorry. Divided by 2.04175. 0.020875 multiplied by 0.02091 divided by 2.04175. So what is the answer? Yeah, T13 equals to, yeah, calculate, yeah, calculate. Zero point 0.00021, yeah, 5 decimal place, Nor Ain. Yeah, Chao Jet is correct. Five decimal places. If you can go more than 5 is okay. Yeah, we take 0.00021. Okay. So the answer is T13 0.00021. Okay, T13. Now you go for the fourth equation. T14 equals to 2.0875 plus 0.020875 multiplied by T13 divided by 2.04175. But T13 is 0. T13 is 0. Is already initial condition. T13 is 0. Therefore, 2.0875 divided by 2.04175. I repeat again, 2.0875 divided by 2.04175 equals to what? 5 decimal places. Yeah, you got to practice class. This is experimental work, 1.02241. Okay. All right. So anyone else? Can you verify? Yeah, anyone? Please verify. Same, sir. Okay. So now you already have T1, T2, T3, T4. So the answer is the same. Okay. So you already got T1, T2, T3, T4. All right. So all these, the answer you already got. This is first iteration class. So now all of you are familiar with Gauss-Seidel method. So this Gauss-Seidel method will not be given. When they ask you to solve the system using finite difference method, you select Crank-Nicolson method, and want to solve the system, you must employ Gauss-Seidel method. Now, this one is first iteration. First iteration is the T superscript 1 is the time at 0.1. So if you want to find T superscript 2, then we move on to the next time, T 0.2. But since we want to calculate T1 again, but second iteration, like what you have done before. Okay, you go back to the slide, this one. See this one, second iteration, but T1, all T superscript 1, that means still in level at T 0.1 second, you got this answer by doing this calculation. But must use the first iteration, you got this by Gauss-Seidel. Using this, you calculate for the second iteration, but still at T 0.1. The reason for this is we want to calculate the error. So we already done for this problem. So I'm going back to the slide of this one. Now slide 23. You see this one is nothing to do with the level. This one, the temperature I, subscript I, all same. T subscript I. But superscript K represent the iteration. So one iteration, you cannot find the error. If you look at the previous example, we already shown the error for the temperature 1, 0.04%, temperature 2, 0.1%, temperature 3, 96.12%, temperature 4, 0.004%. That is for the implicit, for this method. For the implicit method, simple implicit method, we use the two iteration, iteration 1, T1, T2, T3, T4. Iteration 2, still you calculated T1, T2, T3, T4. They stop here. But we went one more step ahead to calculate the error. So the error, actually, we found out the T1 0.04%, T2 0.1%, T3 96.12%, T4 0.04%. Similarly, we want to do for Crank-Nicolson method. Now we want to use the same equation and then use these values to calculate second iteration. So iteration 2. So iteration 2, now we want to calculate iteration 2. So iteration 2, start, yeah? You have to start now. Iteration 2, your T11, using the formula again, yeah? Iteration 2, 4.175. The same system same. You use this system. This system same. T12, T11 equals to 4.175 plus 0.020875 T12. But the T12 now is 0.02091. Change. Divided by 2.04175. This is new now. Now we are in iteration 2. You calculate T11. So what is answer, class? But iteration 2, yeah? But still, we are calculating T11. 4.175 plus 0.020875. The T12 now becomes 0.02091 divided by 2.04175. So you give us the answer. What is the answer? T11. Now we are doing for iteration 2, but temperature T11. Yeah, what is answer? 5 decimal places. Two point zero four five zero three. Yes. Yes. Anyone? 2.04503. Yeah. Yes. This is T11. You have to do the calculation, class, for the next assignment. 2.04503. Okay. Yeah. So all of you agree or disagree with the answer? Yeah. Anyone disagree? If you agree, please write down. Yeah. Chia. You agree with that answer, Chia? So T11. Yeah, we are calculating T11. Yes, Chia. Yan Cheong. Yeah. Muhammad Aiman. Muhammad Aswar. So anybody else? Muhammad Aswar. Agree. Okay. Amanda. Okay. Okay. All right. Okay. Now we proceed. Yeah. Now T12. T superscript 1, subscript 2 from equation number 2. T12 equals to 0.020875. T13. T13 you already have. So T13 is 0.0021 plus 0.020875. T11. T11 you have to substitute 2.04503. I repeat again, yeah, divided by 2.04175. So I repeat again, T12 equals to 0.020875 multiply by 0.00021 plus 0.020875 multiply by 2.04503, that is T11, divided by 2.04175. So equals to what? 5 decimal places, T12. So T12 equals to what? Yeah, you got to calculate, class. You have to practice. We always ask you to do this calculation because the numerical calculation is like that. Otherwise, you cannot move to the next step. 0.02091. Yes. Okay. Anyone else? 5 decimal places. 0.02091. T13. Sorry, T12. Yeah. T12. Okay. Good. All right. Now T13. T13 equals to 0.020875 multiplied by T14. T14 is 0. T14 is 0 plus 0.020875 T12. T12 you already obtained 0.02091 divided by 2.04175. So you should able to calculate 0.020875 multiplied by 0.02091 divided by 2.04175 equals to what? T13. Iteration 2, yeah? Zero point 0.0021. No. No. 0. No. Natasha. No. 0.020875 multiplied by 0.02091 divided by 2.04175. 0.01067. Yes. Yeah. Chaujit and Patricia. Yeah. Correct. Sorry, sir. Okay, no problem. Take it easy, class. Take it easy, eh? Take it easy, relax. Easy, easy, eh? No problem. You made mistake, you correct it. You make mistake, you correct it. That's why we want to do this kind of instance on the spot calculation. So you know, if you make mistake, you can correct it. No problem. Yeah, take it easy. You can practice. Still, you have plenty of time. So you can keep on practice. The important thing is you have to do. Make correction, yeah? Make correction, and then go for the correct one. Make correction, go and study, yeah? Have ample of time. Go slowly, yeah? Slow and steady. Relax. Chill and relax. So now, the last one, T14. T14. Iteration 2, yeah? Iteration 2, T13. Now, iteration 2, T14. T14 equals to 2.0875 plus 0.020875 T13 divided by 2.04175. But T13 is 0. T13 is 0. So therefore, 2.0875 divided by 2.04175. So what is the answer? 2.085 divided by 2.04175. Yeah. Anyone? Yeah, answer please. 1.02, 1.02241. Not yet. Calculate again, class. 2.0875 divided by 2.04175. Yao Kong. 1.02252. No, T14. Sorry. Yeah, T13 is 0. T13 is 0. This is the initial condition. Answer is 1.02252. Yeah. Yao Kong is correct. Patricia, T13 is 0. So the answer is 1.02252. T13. T iteration 2. Oh, sorry. Yeah, I see. That is for iteration 1, right? Is that correct? T13. T13, we have to use, we are in iteration 2, right? Iteration 2. Sorry. For T13, we use T for third equation T13. T12 you use 2.0. 0. Okay, class. Sorry, class. For T11, sorry, for T11, iteration 2, yeah? Okay, please check, yeah? T12, we use from iteration 1. For T12, okay. T11, okay. T12, okay. T13, 0.020875. T14, 0.020875. T12, 0. Okay, T13, 0.0167. Yeah, T14, please correct, yeah? Yeah, yes. Yes, yeah, calculate again, sorry. T14, 2. So T14, 2.0875 plus 0.020875. T13 is 0.01067. Sorry, class. Divided by 2.04175. Yeah. Please correct, yeah? T14. Okay, do it again. Yes, yeah, you are right. So do it again. 2.0875 plus 0.020875 multiplied by 0.01067. Yeah. So what is the answer? Divided by 2.04175. Yes. You are right, Patricia. Sorry, yeah? Yeah, calculate again, class. 2.0875 plus 0.020875 multiplied by 0.01067 divided by 2.04175. Yeah. Yeah, your answer, please. Yeah. Anyone? Yeah, redo again, yeah? Yeah. Natasha, can you redo again? Yao Kong, Patricia, what is the answer? Yao Kong, 1.02252, same. 0.020875 multiplied by 0.01067 divided by 2.04175. So our answer is the same. Okay. Okay. So at least we have calculated with the correct value, yeah? Okay. Now you already have T1, T2, T3, T4. So we want to calculate the error. Okay. The error, the last part, yeah? The error for temperature 1, T1. So you see this one, the slide is here. So we want to calculate the error to show which method is the best. So the epsilon error equals to T superscript K plus 1 subscript I minus T superscript K subscript I divided by T superscript K plus 1 subscript I multiplied by 100%. Less than epsilon subscript S. This epsilon subscript S is not given. So we do not know what is the percentage is required. So you just have to calculate the error. So in order to calculate the error, which we call here is convergent, the convergent, the rate, the lesser is the best. So the error will be less, then the accuracy is very high. So the error for the temperature 1 is T superscript 2 subscript 1 minus T11 divided by T12. But the K is not L, yeah? K is the iteration. So second iteration for the temperature 1 is 2.04503 minus for the first iteration 2.04481 divided by 2.04503 multiplied by 100%. So what is your answer? This is the error. Two decimal places is enough. Or at most you can go 3 decimal places. 2.04503 minus 2.04481 divided by 2.04503 multiplied by 100%. So what is your percentage? Yeah. 0.01. Yes. Yes. Yeah. Percentage. Yeah. Yes. Great. Yeah. 0.01%. That means the error is very low. Huh? The error is very low. So if you compare with the previous one, previous method, implicit method, you have error 0.04. So in this case, 0.01 is less than 0.04. So for the temperature one, Crank-Nicholson method gives best temperature. The output is good. Okay, so the output is good. So very less. So the percentage of error is very less. Now, for the temperature 2, temperature 2, T2, again, T2 subscript, second temperature 2, 0.02091, 0.02091 minus 0.02091 divided by 0.02091 multiply 100%. Temperature 2. What is the answer? Yeah, 0%. Yeah. Yeah. Yes. Great. Yes. Yeah. So that means the error is very small. The stability is very strong. So almost very stable. So stability is very high. 0% error. Now for T3, 0.01067 minus 0.00021 divided by 0.01067 multiplied by 100%. Zero 0.01067 minus 0.0021 divided by 0.01067 multiplied by 100%. T3, Sunijit, 0.01067 minus 0.0021. T3 second iteration, 0.00021. 98.03. Yes. Sorry, sir. Silap. Yes. Yes, yes. Yeah. Yeah. 98.03%. Yeah. Yeah. So 98.03%. Yeah. So that means the error is very high, higher than the implicit method. Because if you check the implicit method, 96.12, the error. But this one, 98.03. So for T3, Crank-Nicholson method gives very high error. That is a conclusion. Okay. Last one, T4. So T4 1.02252 minus 1.02241 divided by 1.02252 multiplied by 100%. This is for T4. 0.01. Yes. Yeah. Yes. Yeah, Suniljit. Yeah, Suniljit. Great. 0.01%. So if you compare with the implicit method 0.04. So Crank-Nicholson 0.011 or 0.01. So in this case, Crank-Nicholson better than this implicit method. So overall, out of 4 temperatures, T3 only the error is higher than implicit method. So the Crank-Nicholson method outweighed the implicit, simple implicit method in finding the temperature, the output, the quality of the output for Crank-Nicholson method better than implicit method. So you're comparing two methods, yeah? Simple implicit method and Crank-Nicholson method. We are not comparing with what we call explicit method. Explicit method you can do for T0.1 and then T0.2 because for explicit method we don't use Gauss-Seidel. So it was not suggested. So Gauss-Seidel only for implicit as well as explicit, implicit and Crank-Nicholson. But if you want to use Gauss-Seidel for explicit, you can give it a try. Still, but you have to develop the system of equations, which we didn't do for the explicit method. Okay, now any question, class? Going back to the slides. So any question from all this for the 5.2? Finance difference method, explicit, simple implicit, and Crank-Nicholson. So if you go back to explicit method, we calculated at T 0.1. This is the answer. And T 0.2 we already calculated. So you can find the error if you want. But here, this is a very simple system. So they don't want to use Gauss-Seidel. So they just use the normal method. They calculated the temperature, T at 0.2 and T at 0.1. I already gave you the answer, T at 0.2. For simple implicit method, we have that equation. Is already given, the famous equation. You have to use this equation to start with the system. And then you come to the point where you create this linear algebraic system and you solve at least 2 iteration, class. And this is where first iteration and second iteration. And then we already solved the error. For Crank-Nicholson, also same. But what is given here is for first iteration only. And we went to second iteration and we've calculated the error and we justify which method is the best method. Because you will be asked to justify which method is best method. Okay, any question, class, before we stop? So any questions on chapter 5? No, sir, all clear. Okay. So in that case, for test 1, yeah, take note, yeah, test 1 coming Sunday, 29/11/2020, 9 p.m., chapter 3 and 4. Okay. So please refer to your ULearn. No, test 2. Duration, I'm not sure. Duration, I do not know. You wait. Please wait. Please wait. Please wait for the instruction from the coordinator. Please wait for the chapter 3 and 4. Number of question, I'm not sure. Yeah. So those of you doing replacement quiz 1, you please wait, yeah, via email, yeah. So I will ask you to submit via email. The best we can do is next week. Next week is the final week. Now we are week 11. Week 12 is the final week. We will do the final revision. Okay, that's all, class. Shall we stop here? Yeah, very soon. Yeah, test 1 marks will be out very soon. Yeah, very soon. We are working on it. Yeah, Mohammed Shalin. Mohammed Salihin. Yeah, test 1. Yeah, still going on. Marking still going on. Okay, see you next week. Have a wonderful weekend. Please fill up. Please fill up your satisfaction poll. Yeah. Please fill up your satisfaction poll at ULearn. We will announce the coursework mark one shot. Yeah. Coursework mark. Coursework marks next week. Yeah. Okay. All right. So that's all, class. Okay, Amanda. All right. So we will stop here. Eh? So I will hang up and see you next week. Any question, class? Yeah, Sankita. Any question? Sankita. Any questions? All right. So that's all. Yeah. Okay.